Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following trigonometric equations with double angles. Please don't forget to click on the like and the subscribe button below for more easy to understand math concepts. We have to solve for x such that 0 degrees is less or equal to x and x is less or equal to 360 degrees. That's the interval given. A sine 2x minus sine x equals to 0. And b cos 2x minus cos x equals to 0. Starting with the first equation, we have sine 2x minus sine x equals to 0. We can see the double angle identity. We have sine in bracket 2x, and the identity states that sine 2a equals 2 sine a cos a. In this case, our a is x. So if I rewrite my equation, I have 2 sine x cos x minus sine x equals to 0. Factorizing, you can see that sine x is common to the two terms. So if I factor out sine x, I'm left with 2 cos x minus 1 equals to 0. So to solve this equation, I have sine x equals to 0 or 2 cos x minus 1 equals to 0. I'm going to solve the two separately, starting with sine x equals to 0. If I go back to my cast diagram, I have my CA, ST. Note that sine is positive in the first and the second quadrant. So starting with my reference angle will be arc sine of 0. That's I'm moving my sine to the right hand side. And if I check for arc sine of 0, my reference angle will be equal to 0 degrees. And we've been able to state or show that on my cast diagram, I have sine being positive in the first and second quadrant. So therefore, the first value of my x equals to 0 degrees, or my theta as shown. And the second value for x will be 180 degrees minus my reference angle. That's 180 degrees minus 0 degrees, which is equal to 180 degrees. I need to solve for 2 cos x minus 1. So if I rewrite that, I have 2 cos x minus 1 equal to 0. If I solve for cos x, I have 2 cos x equals to positive 1, dividing both sides by 2. I have cos x equals 1 over 2. If I go back to my cast diagram, you can see that cos is positive in the first and the fourth quadrant. So therefore, I'll start by finding my reference angle. Reference angle equals arc cos of 1 over 2. And if I have to find the arc cos of 1 over 2, that's equal to 60 degrees. Therefore, for my first value of x, going by the first quadrant, x is equal to 60 degrees, which is my theta. And for the second value of x, that will be 360 degrees minus my reference angle. That's equal to 360 degrees minus 60 degrees. Therefore, the second value of x for 2 cos x minus 1 will be 300 degrees. And note that all these values of x falls in the interval 0 degrees less or equal to x less or equal to 360 degrees. For the second part of the equation or the question, I have cos 2x minus cos x equals to 0. I can see my double angle in the brackets, that's 2x, and using the identity for double angle for cos or cosine, I have cos 2a equals, I have that as 2 cos squared a minus 1. Note that cos has 3 different options for the double angle, but I choose to pick the 2 cos squared a minus 1 because I want to factorize. I have my cos x in my second term, and I know I can easily factorize from there. So rewriting my equation, I'm going to break down my cos 2x into 2 cos squared x minus 1 minus cos x equals to 0. Note that to factorize, this is similar to your quadratic equation. If I rewrite that, I'm going to solve that on the right. I have that as 2 cos squared a x minus cos x minus 1 equals to 0. If I factor, so I'm going to rewrite what I have here to be 2 cos squared x minus cos x minus 1 equals to 0. So therefore, I'm going to factor my left-hand side. I have that as 2 cos x plus 1. And then I have cos x minus 1. Note that if I FOIL or expand what I have, I must be able to get my original equation of 2 cos squared x minus cos x minus 1. Therefore, to go ahead, I have 2 equations equals 0, so I have 2 cos x plus 1 equals to 0, or cos x minus 1 equals to 0. I'm going to solve both differently. For the left-hand side, I have 2 cos x equals to negative 1. Therefore, my cos x equals to negative half. I'm dividing both sides by 2. If I go back to my cast diagram, as shown, I have C, A, S, and T. Note that cos is negative because I have minus 1 over 2. Cos is negative in the second and the third quadrant. I have that as 180 degree minus theta. I have 180 degree plus theta. So therefore, to find my reference angle equals to arc cos of, I'm going to ignore the negative sign, so that'll be arc cos of half. And to find the reference angle, arc cos of half will be 60 degrees. Going back to my value of x, I start with the second quadrant. I have x equals 180 degree plus my reference angle. That's 180 degree plus 60, and that's equal to 240 degree. I've started with the third quadrant. Going back to my second quadrant, x will be 180 degrees minus my reference angle. So that's 180 minus 60, and that's equal to 120 degrees. Note that these two values still fall within the interval 0 degree is less or equal to x, and then less or equal to 360 degrees as given in the question. We're done with the left hand side. We need to solve for cos x minus 1 equal to 0. Therefore, moving my negative 1 to the right hand side, I have cos x equals to positive 1. If I go back to my cast diagram, cos is positive. I'm going to take out for the first part. You can see cos is positive in the fourth, and the first quadrant. We have that as 360 degrees minus theta. We have this as theta. So therefore, to find the value of x, we have, using the first quadrant, we have reference angle equals arc cos of 1. Therefore, reference angle equals 0 degrees. So therefore, the value of x using the reference angle will be 0 degrees. That's in the first quadrant, it remains theta. And in the fourth quadrant, x equals 360 degrees minus your reference angle. That's 360 degrees minus reference angle is 0. So therefore, x equals 360 degrees. Thanks for watching. Bye.